Welcome back to the Cave of Science, and today we're going to look at bond dissociation energy. Bond dissociation energy is the enthalpy change, and enthalpy, if you remember, is a measurement of energy, and this is the energy required to break a particular bond in 1 mole of a gaseous diatomic molecule, or molecules. So delta H would equal the sum of all the bond energy that it takes to break the bonds of the reactants minus the sum of all the bond energies of the bonds that are produced in the products. Now, a couple of things we need to remember here is these must be gases. So what we're working with are gases. And also, if delta H is positive, delta H is positive, then it's an endothermic reaction. Here, if delta H is negative, then we've got an exothermic reaction. And we'll do a couple examples of these, of what's happening here. All right, so let's do an example. Let's take hydrogen, and again, it's going to be in the gaseous state, plus chlorine in the gaseous state. In the gaseous state. And you always got to work with a balanced equation, and goes the hydrogen chloride in the gaseous state. So if we balance this out, see we got 1 mole of hydrogen gas plus 1 mole of chlorine gas will give us 2 moles of hydrogen chloride gas. This is also where your Lewis dot diagrams come in. So we're going to take a look at what's happening here on the reactant side. So if we look, we've got H2, so we have a HH single bond, and we've got chlorine, so we got Cl, Cl, and again, that's also going to be a single bond. Now these are the ones that are broken. And what is being formed, so we're forming, I'll get that up a little bit, or our products, if you will, are forming. We have HCl bonds, but we've got 2 of these because our coefficient here is 2. So we've got 2 of these bonds being formed. Now you may ask, okay, that's good, we've got that together, but where do we get our values from? Well, there are many tables out there. You can find these all over if you Google them. And this is one I picked up. So we're going to look at the bond dissociation energies, and these are averages. And notice we're working in kilojoules per mole. So we're definitely going to need a hydrogen-hydrogen, so we're going to be using this one. And we also have a chlorine-chlorine bond. So if we look around on our table to see if we can find the chlorine-chlorine bond, we find that's down over here. And then the one that is being formed is the HCl. So if we look, and we find the HCl is here. So if we look on our table, we can find those bonds there. So let's go ahead and put these values into our equation here. So the HH is 436 kilojoules per mole. The chlorine-chlorine, as we saw, was 243, and that's kilojoules per mole. And then the forming, we have HCl, and that is 432 kilojoules per mole, but we have 2 of those, so we got to multiply that by 2. So that will give us 864 kilojoules per mole. All right, so now we've got that. We can go ahead and plug them into the equation there. So we can go back to our equation up here. We got our bond energy of reactants and bond energy of the products. So we can go ahead and plug those in. So our delta H, again, the summation of the bond energy of the reactants. So we have here, we have 436. So we'll get our summation. We got 436 plus 243. And then we're going to minus our summation here, which is going to be 864. Oops, I forgot the 64. 864. So if we work this out, we'll end up having, let's see, 679 minus 864, and that's going to give us a negative 185 kilojoules per mole, and so that's going to be exothermic. So we have that for our first example on there. So let's go ahead and we'll do another example. And we're going to do a real common one where we have water. So let's get this out of here, out of the way. And let's go ahead and look at water. So we know water, and again, we're doing it in the gaseous form. So hydrogen in the gaseous plugs O2, and that's going to give us H2O. Well, if we got to go through, oops, sorry on that. If we go through this, we got to go through and balance the formula. So we put a 2 here, and we got a 2 there, and it looks like we're balanced. So now let's take a look at our bonds that are broken, or our reactants. So we have we got HH, which we have 2 of those, and that comes from here. Now oxygen, that is a double bond down there, and we have 1 of those. And what's being formed we have OH bond, and it's H2O, so we have a water. If you remember, we got this bond, oops, and we've got that bond. So we got these 2 bonds that are going to be formed, and we have 2 moles. So we're going to have, we got 1, 2, 2 times 2 would be 4. So we have 4 of those being formed. Now we can go back to our table, because we actually got 2 moles being formed there. All right, we go back to our table. So for hydrogen, we can look at this. We got HH, we know is 436. And again, these are all going to be kilojoules per mole. We have an oxygen double bond, and you can see down here we've got the double bonded oxygen. And it looks like it's going to be 498. So it's 498, and that's kilojoules per mole. And the OH bond, go back into here, let's see if we can find OH. Here it is right here, and that's 460. So we've got 4 times 460 kilojoules per mole. And if we go ahead and multiply that out, we're going to get, that's going to equal 1840 kilojoules per mole. All right, from there we can go back into our formula. So we got our delta H, and that's going to equal our summation there of the bonds that are broken. So we have 436, well, we got 2 of those, so that's going to be 872. So we got 872 plus our 498 plus 498 minus the sum of all the ones that are being formed. And we've got 4 of these at 460. So that's 1840. And if we can go ahead and finish off the math here. So delta H, it should be 1370 minus 1840. And if my math is correct, we should have 470 kilojoules per mole. And let me check my math here real quick. And it's going to be a negative value of 470 kilojoules per mole. And again, we got a negative value there, so we're going to be exothermic again. So, and that's all as you're working these problems. You know, get your tables, figure out the number, what type of bonds, and how many you are breaking. If you forget anything, don't forget to multiply by the coefficients. That's where a lot of students make a mistake with that. All right, so with that, we'll see you next time.